that is what is called a rectifier. Okay, so PN junction diode as a rectifier. So what is a rectifier? A rectifier, it is a device which is used for converting alternating current or alternating voltage to the direct current or direct voltage. So PN junction diode, okay, it is used for, okay, converting. It is what is application? Converting alternating current or voltage. Let it either current or voltage to the direct current. Direct current or voltage. So which means that this is used for converting AC to DC. Okay, AC alternating voltage to direct voltage. Okay, therefore this is now the how it works we are going to see. Okay, so listen, therefore first one is there are two types of rectifiers. One is what is called half wave rectifier and another one is what is called full wave rectifier. Okay, so what are they? See here, as I told you, what is a rectifier? Rectifier, it is a device which is used for converting alternating current or voltage to the direct current or voltage. And this process is there, no? The process of converting AC, alternating current to direct current, alternating voltage to DC voltage, direct voltage is what is called rectification. This process is what is called rectification. Okay, so right, now we are going to see there are two types of rectifiers. One is what is called half wave rectifier and the other one is what is called full wave rectifier. Now we are going to see both. Okay, first one is what is half wave rectifier, how it works we are going to see. See, in the case of half wave rectifier, very simple. We are using a transformer. See, this is a transformer. Here, this is the primary of the transformer. And the primary of this transformer here, P1, P2. That coil is there through ends. It is connected to the AC, which is to be transformed, which is to be converted. Okay, therefore, which we want to convert, because it is meant for converting AC to DC. So, the alternating voltage which is to be converted into direct voltage, DC voltage, that is to be given as an input. This here, it is an input. Okay, therefore, this is AC. AC input is given. To what? Transformer. You know transformer works only on AC. Okay, therefore, primary of the transformer is given the input. And therefore, what happens? The secondary, you have, I think, idea about the working of a transformer. What is that? What is the principle of working of a transformer? It is nothing but mutual induction. Therefore, what happens as you are giving to primary alternating voltage is given. Therefore, its voltage will be continuously. See here P1. P1 is connected first if it is negative first half cycle, then next half cycle it will become positive because alternating, you are giving alternating voltage. Therefore, for one half cycle if P1 is negative, P2 will be positive. That is why I have given positive. And for the next half cycle, P1 will become positive and P2 will become negative because it is connected to an AC. Okay, input is a AC voltage, right? Therefore, what happens? When, for example, to start with, the P1 is negative for the first half. So this is the first half cycle. Okay, for the first half cycle, what is that? P1 is negative. P1 is negative. Okay, when P1 is negative, you see, see, P1 is negative, then what about, see, S1, this is a secondary. Secondary, see, whenever there is a change in the, flux linked with the primary, okay, and EMF is induced in the secondary because the principle is nothing but mutual induction. Therefore, definitely there will be EMF that is induced in the secondary, but it will oppose. Therefore, see, you know that it is Lenz's rule, right? Therefore, now when primary is negative, P1 is negative, P2 is positive, okay, at first half cycle, that time there will be an induced EMF, okay, across the secondary coils S1 and S2 such that S1 will be positive and S2 will be negative. Okay, when P1, P1 is negative, P2 is positive, that time S1 will be positive and S2 will be negative. Okay, it is only on the basis of Lenz's rule. So, the basic thing here is nothing but what is that here? Mutual induction. Due to mutual induction, what happens? Primary of the transformer, here it is nothing but transformer principle is nothing but mutual induction. So your input is connected to the primary of the transformer, and the secondary of the transformer, there will be an induced EMF, and hence there will be an induced current. Okay, to start, once again, very important thing is what is the principle involved. See, what is the principle here? You know, see, principle of rectifier, because you know what is what is application. It is meant for converting AC to DC, right? But what is the principle involved? The working principle is nothing but it is based on the fact, the working of a rectifier is based on the fact that the resistance of PN junction diode is very low when forward biased and very high when it is reverse biased. That is the principle. Working principle is nothing but the junction diode, the PN junction diode offers very low resistance when it is forward biased, and when it offers very high resistance when it is reverse biased. That is the working principle of what is that rectifier. Okay, rectifier. So now on this principle only it works, right? Therefore, now you see, coming back to this, see, half-wave rectifier, the primary of a transformer is connected to the AC, which is to be rectified, and secondary here, how is it connected? Use secondary of the transformer. S1 and S2 are two terminals of the secondary, and this S1 here is connected to a rectifier here, diode, PN junction diode, and therefore the N-type, that is N-type semiconductor is there. No, that is connected to load resistance, and through the load resistance, then it is S2 is connected. After that, it is S2. S1 is connected to a junction diode. Through that, will be a load resistance, and the other end of the load resistance is connected to S2. That's very simplest circuit. Okay, but where are you getting the output? Then output will be taken across the load resistance, that is RL. Across this, you will be getting the what is called the output. Okay, rectified output. That is nothing but DC output. Okay, right. Now, how it works? See, to start with, let us consider the first half cycle, this half cycle. Here, I am giving, this is the input. Now, input is AC. AC input. Correct? It is AC input only, na? Okay, therefore, this is the AC input. Okay, but what, see, here, it has both positive half cycle and the negative half cycle. Now to start with first half cycle here. That time, what is a P1 is negative, P2 is positive, for example. Therefore, S1 will be positive and S2 will be negative. You know that one because it opposes the Lenz's rule. Okay, so S1 now in turn, it is S1 is positive now. For the which half cycle? The first half cycle. This one, the first half cycle. This is the second half cycle. And this is third, like that. Okay, okay. Therefore, in the first half cycle, what is that? S1 is positive. S1 is positive means, see, P is connected to positive. Therefore, the P here. Okay, PN junction diode, P is connected to positive and S2 is negative. No, therefore, N through the resistor or load resistor, it is connected to negative. Therefore, P connected to positive, N through this load resistor, it is connected to negative. Therefore, that is negative means S2. Okay, P is connected to S1, N is connected to S2. P is connected to S1 means S1 that time it is positive. Therefore, P is connected to positive and N is connected to negative during the first half cycle. Okay, therefore what happens? Now the junction diode offers very low resistance. Okay, therefore it conducts electricity because the resistance is very less. And that too, usually we will use here in the rectifiers, where the diodes are called, we are using ideal diodes. What do you mean by ideal diodes? Ideal diodes means which offers, see, the diode which offers zero resistance in forward biased, low, and usually what is that? P-N junction diode offers low resistance when forward bias, high resistance when reverse biased, right? This is a characteristic of a junction diode. But here, what is the ideal diode? What are ideal diodes? Well, the diodes which offers zero resistance, not low, zero. Zero resistance when forward biased, infinite resistance when reverse biased. Infinite resistance when reverse biased. Therefore, it will not allow any current to pass through it when it is reverse biased. Okay, so but when it is forward biased, what is that? It allows a full current. Therefore, zero resistance is zero. That is ideal case. That is why it is called ideal diodes. Okay, right. Therefore, here let us use here, if you feel that if you consider that the diodes are ideal diodes, therefore what happens here? During during this half cycle, first half cycle, there is a positive half cycle. Therefore, what happens? S1 is positive, S2 is negative. Therefore, the diode here is a forward bias. Therefore, it will conduct. Okay, it will allow current. Therefore, the current will be passing through in this direction. Therefore, current passes in this direction and it will. Okay. Therefore, what is the direction of the current here? It is from, this is positive and this is negative. Therefore, the current in the resistor, it will be in this direction. Okay. Therefore, through the resistor, you can take the voltage across the load resistance. Whatever the voltage, whatever you are getting is nothing but output voltage. Okay. Therefore, now therefore, if you plot here, see here, this is the first half cycle input to I say here. Okay, this is the input, and what will be, you will be getting exactly no problem at all. It allows whatever current is there, the PN junction diode allows, and you will be getting here, it is the output. It is the output. So, for first half cycle, PN junction diode conducts, fully it conducts. It allows the current. Therefore, whatever current is passed, everything is allowed. Therefore, you will be getting here, this one is the output. Okay, therefore there won't be any change in the amplitude, nothing, just like whatever is there, input, everything it allows, therefore you will be getting the output. Okay, during the first half cycle. Next one, next half cycle, see for example, here you would see the primary of the transformer, primary, P1 becomes positive and P2 becomes negative in the next half cycle. Okay, therefore your S1 becomes negative and S2 becomes positive. Hope you are following. In the second half cycle is May, second half cycle. When second half cycle of the input. Okay, and the second half cycle of the input, what happens? Okay, P1 becomes positive, P2 becomes negative. Therefore, S1 becomes negative, S2 becomes positive. S1 becomes a negative. S1 becomes a negative means P is connected to negative. And S2 becomes positive means N is connected to positive, P to positive, N to negative. Therefore, which means that it is reverse biased. Hannah, the previous case, it is forward biased during the first half cycle. Okay, P is connected to positive, N is connected to negative. Why? S1 is positive, that time S2 is negative. Therefore, it is fully forward, but diode is forward bias, so it allows the current. But during the second half cycle, S1 becomes negative and S2 becomes positive. Therefore, P, the junction diode, P of the junction diode is connected to negative and N is connected to positive, which means that it is reverse biased. So, reverse biased means if it is an ideal diode, it will not allow any current to pass through it. Okay, because it offers very high resistance. You know the working principle itself is that the diode offers low resistance during forward biased, when high resistance when it is reverse biased. Okay, therefore now because it is reverse biased, that too we are using, if you're using an ideal diode, it will not allow a current. Therefore you see what is output, there is no current through the load, therefore nothing will be there. You see here, this is current is fully wiped out, the voltage whatever, there is no current through the circuit. Now here there will not be any current in the circuit. This current here, it is only for the first half cycle. Okay, now there won't be any current, therefore it will be wiped out. Therefore this is the for second half cycle. Here it is everything, there won't be any output because your diode is reverse biased, right? Then once again the same thing repeats. Then third half cycle, that is once again positive half cycle. During the positive half cycle, once again P1 becomes negative, P2 becomes positive, S1 becomes positive, S2 becomes negative. Therefore the diode is forward biased, it allows the current, therefore you will be getting the output. Okay, and the next one, fourth half cycle, once again it will not allow. Therefore, which means that the diode, the rectifier, half wave, that is why it is called a half wave rectifier. See, only one half of the positive half cycle here of AC input, positive half cycle of the input, A hai, oh, तीनों. Okay, that only is allowed. A negative half cycle is fully wiped out. It won't even respond to the negative half cycle. Why? Because that time the diode is reverse biased. Okay, therefore this is what is called half wave rectifier. You will be getting only one half of the, in full cycle, half the cycle is rectified, other half cycle it will not even respond to, it is fully wiped out. Okay, therefore that is why it is what is a half wave rectifier. Half wave, see, half the wave of the input is rectified. So it is what is a half wave rectifier. Okay, hope that you are able to understand. Therefore you see the same thing whatever I have done, see here, because see the same thing here. Okay, this is a input is full wave and here output is half the wave. Okay, therefore half wave signal. Same thing here, the same diagram, everything, see, it is drawn the circuit diagram. If you want, you can see this one. See here, whatever I have drew here, the same thing here. Okay, that this is about half wave rectifier. But what is the problem here? Half wave rectifier, because half the cycle only it is responding, next half it is not responding now. So it's of no use. It doesn't have any practical use actually. Okay, the full wave rectifier. So half wave rectifier is not of that use. Therefore that is why we are going for the next one, what is called full wave rectifier. Okay, what is full wave rectifier? We are going to see now. Okay, so see, it is half wave. Once again, wait. Yeah, this is a full wave rectifier. You see, it is full wave rectifier. What do you mean? See here, what happens? See, in the case of full wave rectifier, the circuit diagram is different, you see. Here, the same thing. See, here it is an input, AC input. This is nothing but AC only. There is no need to say now. Okay, it is an AC input. And the same thing, transformer is used. Primary of the transformer is given, is connected to the input, and secondary of the transformer. See, secondary, there are two terminals. See, in the secondary there will be so many terminals will be there. Okay, therefore here we have see here, it is S1 and S2 secondary, and in here we are going to take one more terminal. This is what mid tap. It's what's called mid tap. Okay, therefore when S1 is positive and S2 is negative, okay, so S1 to S2, S1 is positive and S1 is positive and S2 is negative. Therefore as you go from S1 to S2, okay, the potential here you see it will decrease and S2 becomes negative. Okay, like that when therefore here mid tap, let it be given a O. Let it be O. Therefore, O at this time, O will have less potential, less positive when compared to S1 and more positive when compared to S2. Why? Because S2 is negative as you come from S1 to S2, therefore the value, it becomes positive value, it decreases, okay, and S2 it becomes negative at negative potential. Therefore O will be having O's potential of O will be less than S1 and more than S2. Are you following? But when S1 becomes negative and S2 becomes positive, therefore, as you go from S1 to S2, the potential gradually it will increase. Okay, because S1 is negative, S2 is positive. Therefore, potential of O now, it will be more positive when compared to S1 and less positive when compared to, its potential is less when compared to S2. Okay, is it clear? So this is what I am taking in S1, S2, two terminals. In between one terminal also I am taking, that is what is called mid-tap. Just I am explaining this, right? Okay, so with this, let us go here. Therefore the circuit diagram, if you see, the circuit is like this. See, S1 and S2 both are connected to a diode, D1 and D2. Let it be an ideal diode, D1, D2, and they are connected here, and here there is a load resistance RL. Okay, in between there is a load resistance, across the load resistance you are taking an output. That's all, very simple circuit. In the case of half-wave rectifier, you are using only one diode, but full-wave rectifier you are using two diodes here. That's it. Okay, that is the difference, right? Okay, now to start with the first half cycle. During the first half cycle, here this is the first half cycle. At the time first half cycle, P1 is negative, P2 is positive, like that only we have taken in half-wave rectifier. Let it the same, P1 is negative, P2 is positive. Therefore, S1 will be positive, S2 will be negative. Okay, during the first half cycle, during the first half cycle, what is it? S1 is positive and S2 is negative. If S1 is positive, just you see, listen. Okay, therefore the diode D1 you see. Diode D1, P is connected to S1 and N of the diode D1, and both N of the diode D1 is connected to O. Is connected to O through a load resistor, correct? Right. Like that, if D2, P of D2 is connected to S2 and N of D2 is connected to O through the load. Okay, first understand the circuit. Okay, now during first half cycle, okay, the S1 is positive and S2 is negative. When S1 is positive, see, therefore O's potential will be less than S1 and it will be more than S2. Correct? I told you just now, mid-tap, how it works. Okay. Therefore, now you see P is connected to positive and N is connected to O. Now O is actually, with respect to S1, O is negative. Correct? Why? Because S1 is at higher potential when compared to O. As you come from S1 to S2, in this half scale, only for the first half cycle I am telling, when S1 is positive, S2 is negative. That time, when you go from S1 to S2, the potential actually gradually decreases. Okay. Therefore, what happens here? O's potential will be more than will be less than S1 and more than S2. Okay. Therefore, P is connected to S1, higher potential, and N is connected to O, that is which is at lower potential. Correct? Therefore, P is connected to higher potential, N is connected to lower potential. Therefore, which means that it is forward biased. Correct only? P to positive, N to negative. Therefore, here the same thing. O is at negative potential with respect to S1. For example, if it is 5, if it is 0, and if it is 3, therefore 3 volt, everything. Okay, 3 volt. 3 volt is negative when compared to 5 volt. Okay, which means that P is connected to 5 volt and N is connected to 3 volt, which means that it is forward biased. Like that you have to take. Okay, therefore it is forward by D1 is forward biased. Here D1 is forward. During the first half cycle, D1 is forward biased. You come to D2. D2, if you see, P is connected to S2, okay, and N is connected to O. P is connected to S2 means S2, what is that in that time? It is negative. फर्स्ट हाफ साइकिल में S1 पॉजिटिव S2 नेगेटिव है ना, therefore P is connected to negative but N is connected to O has more potential when compared to S2, therefore O is at higher potential when compared to S2, means O is more positive when compared to S2, therefore which means that your N is connected to higher potential and P is connected to lower potential, which means that it is reverse biased. Okay, during first half cycle, okay, yeah, D1 is forward biased, okay, and D2 is reverse biased. Okay, therefore D1 will conduct but D2 will not conduct because both are ideal diodes. Therefore, what is that? D1 conducts and D2 won't conduct. Because D1 is conducting, okay, therefore there will be the current will be from positive to negative, therefore D1 will only conduct, D2 will not conduct, therefore the current here will be through the output, through the load will be in this direction from right to left, through the load the current will be from right to left. Is it clear? Therefore the current, there will be the output current, output voltage only because of D1 but D2 will not have any say here, therefore here this is due to D1. So you are getting one waveform here that is due to D1, right? Right. Next second half cycle, A half cycle, and this one. During the second half cycle, what will happen? P1 will become positive, P2 will become negative, है ना? P1 will become positive, P2 will become negative. When P1 is positive, S1 will be negative, Lenz's rule. Because mutual induction, S1 will be negative, S2 will be positive. S1 is negative, S2 is positive. S1 is negative means, see, S1 is negative, S2 is positive. O will be at a higher potential when compared to S1 but lower potential when compared to S2. Every time it is changing, you see, we can understand, okay? Therefore, now with that, you can say that P and D1, in D1, P is connected to negative, S1 that is negative, and N is connected to higher potential O. N is connected to O. O is at a higher potential when compared to S1 in the second cycle. Okay, which means that it is reverse biased. Second cycle D1 is reverse biased. Okay, D1 here is reverse biased. Very important. Okay, D1 is reverse biased. And what about D2? D2, you see, D2, P is connected to S2. S2 is positive now in the second half cycle. And N is connected to O. O is at lower potential when compared to S2. Therefore, which means that P is positive, N is connected to negative. Why? Because it is O is at lower potential when compared to S2. Therefore, which means that it is at lower, N is connected to lower potential, P is connected to higher potential, which means that D2 will be forward biased. Forward biased means it will conduct electricity. Reverse biased means it will not conduct electricity. Therefore, in the second half cycle, D1 will not conduct, won't conduct, but D2 conducts. Okay, therefore conducts electricity. Therefore, there will be the current in the circuit. How the current here? Current in the second half cycle will be such that, let me give you with some other color, because current here is second half cycle mein current will be in this direction. First half cycle mein current is only in the upper one, D1. Now second half cycle mein there will not be any current due in the here. Why? Because it is क्या है? ये तो reverse bias है ना. Therefore here current won't be there, just like that. Okay, but the current here is only because of D2. So that only I am giving you in some other color. It is D2. The current here is because of D2. Okay, D1 will not contribute, but D1 will not respond to the input, but D2, because it is forward bias, it will give you current. Therefore here, there will be current here in the output. What do I see? Current here, you see current, it is green, in which direction the current is going through the load? It is once again, it is from left to right to left. Same direction of the current here is only from right to left. Whether D1 is conducting or D2 is conducting, current through the load is in the same direction. Okay, which means that here you are getting this one. It is due to D2. Okay, clear? Then once again the same cycle starts. Therefore, this is due to D1. That time D2 will not conduct. And here this is due to D2, that time D1 will not conduct. Okay, so which means that is why the name is here full wave rectifier. Both the waves, positive as well as positive as well as negative half cycle of the input, both are rectified. Okay, in both the case you will be getting a output, unless your half wave rectifier, it rectifies only one half of the input. Okay, but next half it won't conduct. But here, because there are two diodes, D1 conducts during one half, the first positive half cycle, and D2 conducts during the negative half cycle of the input, so that every time one of the diode is forward biased at every time. Okay, either D1 or D2, so that the current through the load is always in the same direction, that is from here right to left. Is it clear, children? Therefore, now you see here, this is why, because I thought my diagram is may not be very good. That's why, see, this is see, both the halves. That is why it is given D1, D2. I have given a different this one now. So this is positive half cycle and this is negative half cycle, and here both the half cycles are actually rectified, and you will be getting a continuous output. You're getting the continuous output. Okay, the same diagram here, D1, D2, everything is given, whatever I have given here. Okay, so now therefore this full wave rectifier has so many applications. Okay, therefore what are all the applications? See, it is meant for converting AC to DC, but here whatever you are getting is the output, whatever you are getting here due to the rectifier, it will have some ripples, some AC components will be there. It is not fully wiped out. There may be some ripples will be there, and also it is a varying DC, it is a varying DC. Direction of the current is same, it is from right to left through the load, but it is a variable DC, varying, it is not a constant DC. So to get a constant DC, you are using what is called filter circuit. Filter circuit means, what is that? Here the output of the rectifier is there, so this is the output. It is a rectifier. Okay, so rectifier. Okay, I'll write it like this. This is a rectifier. Okay, therefore and output of the rectifier, the output of the rectifier, this is the output of the rectifier. This output of the rectifier is given to a capacitor. It is connected to a capacitor. And after that, there will be a load. And across the load, you will be getting, what is that? Filtered DC, constant DC. Or it is filtered DC. It is what is called filter circuit. It is the AC input that is given to a rectifier. Rectifier means क्या होता है? ये वाला. This circuit, whatever we have seen, rectifier. Output of the rectifier है ना, इधर से output है ना, ये आ रहे हैं ना. The output will be given to a it is connected to a capacitance C, and capacitance, why? Because if at all there is any variable DC, means what is that? All the components, all the other voltages will be filtered by the capacitor. Only, for example, maximum, what is the maximum? 5 volts. If you want that, only that voltage, that particular voltage will be sent, and that will pass through the load resistor, so that you will be getting a constant DC. Constant DC means, if you plot a graph here, well, constant DC, how you will get it is output, and this is time. Okay, so a constant DC means you will be getting like this. No, what is a waveform like? Okay, so here it is a variable DC na. It is a variable DC. So, but when you are giving it to filter circuit, then you will be getting what is that? Constant DC. Constant DC. Therefore, this is meant for. Therefore, you are getting a very, what is that? Says. Constant DC, therefore 5 volts steady. Okay, it is a constant DC. Get it? So that is these things you are using in our lab. It is there. Okay, eliminator. We are using actually rectifiers. That is a different type of, that is a bridge rectifier. There will be 4 diodes will be used. Okay, anyway, the principle is same. Okay, so that you will be getting the filter, the output will be exactly, what is that? You will be getting exact constant DC you will be getting easily. So, therefore there, the 4, what is the diodes will be used. This is basic. From with this itself you will get. But even the better performance will be there. That is what's called bridge rectifier. Okay, therefore you are plugging into AC only, but what you are getting out, see, there will be voltage. You can get 2 volts, 4 volts, 6 volts, okay, 8 volts, like that you will get DC. Okay, but you are giving input is nothing but AC, but what you are getting is different what is that, DC voltages you will get. How? Just there will be a variable capacitor here. When you are tuning it, you are tuning the capacitor value. Capacitor value tune karne se whatever voltage you want. That is, you may get from you are giving 220 volts AC, but you will be getting 2 volts DC, 4 volts DC, 6 volts DC, like that you will get. Therefore, which means that you have converted AC to DC. For that, this filter circuit is very much useful. Is it clear, children? So this is used everywhere. The filter circuit is for converting AC to DC. Okay. Therefore, there will be definitely one transformer will be there. The transformer, what type of transformer? Step down transformer here. Okay, so you will be getting step down. This transformer is nothing but step down transformer, and the transformer with a combination of diodes, then you will be getting with a filter, you will be converting AC to DC. Is it clear? Very simple. That's all. This is what is called full wave rectifier. Okay.